here with the second part of 6.3. Now we're going to talk about compound inequalities where we have an OR statement. The best example I can think about of this is if you think back to elementary school. If you were in elementary school in Wisconsin, you could have a recess canceled or you couldn't go outside if it was too cold. And at least at my school, it was if it was 0 or below, it was too cold. So let's talk about temps where we can't go outside to exercise or to play. Can't play outside. And so we'll stay with that 0 thing. So where can't we play outside? We can't play outside if the temperature is 0 degrees or colder. I forgot how I made this story up, but let's include 0. You know what? I think we were tough back then and we said it was actually sub-0. So I'm getting picky here. I think we went out if it was 0. If we saw that negative sign, then we couldn't. So 0 lets us go outside. Anything to the left of that or colder than that does not. And then recently we've had some hot summers and hot falls where we've had to modify practices at the high school level. 100 degrees heat index is typically where we have to take precaution. And that time it is like if we see 3 digits, including 100, we gotta chill. So here's where we can't play outside. It's either too hot or it's too cold. So this is the OR compound, whereas we were just talking about temperatures where we feel comfortable inside. It's got to be between this and that. So and means between. It makes like a sandwich. ORs mean it's either this extreme or that extreme. What's funny about this is if you're into canoeing at all, I'll draw a bit of a canoe here. Canoe. If you know about canoeing, those are called oars. So it's kind of like our squiggly answer here. One has a white handle and one has a shaded in handle. Those are like oars in a boat. Get it? So like that's a visual, and then ands make like a sandwich. Okay. Not that funny. So let's try some oars. Now these are a little bit less scary because you have like 2 separate equations. Now these 2 separate equations actually coincide and give you your 2 or your 2 parts of the answer. So one inequality, for example, number 6 is right there. And the other one that goes along with it, so this one might give me my cold extreme, for example. It's too cold if it's 0 degrees out to go out for recess. And then this one might give me my hot example. It's too hot if it's that. So these 2 go together. But you solve each one separately, independently solving for x. So like here we would subtract 4 to isolate the x variable. We get 2x is less than 3, and then we divide by 2. So part of my solution is x is less than 3/2. Here we would, so now we'd use a separate algorithm for solving for x. We'd add 5 and add 5 to each side of the inequality. We get 3x is greater than 17, divide by 3, divide by 3. We get x is greater than 17/3. So those are my 2 answers. This is what's too cold for recess, and this is what's too hot to go outside and exercise or have practice. So make sure you put the smaller number on the left. 3/2 is smaller than 17/3. 17/3 is about 6. A little bit less than 6, 5.666, repeating. So our temperature, our solution set is less than 3/2, so we're squiggling that way. Notice the open dot. These are numbers that are less than 3/2. Or our solution is greater than 17/3. So these are the numbers that are greater than 17/3. Again, notice the open dot. Boom shakalaka. That's a compound inequality because we have multiple inequalities, but this is an OR statement. Same here. We have the solution set is either this or that. That's leading us to think that, well, we're probably going to get this OR type picture. So there's one inequality we have to solve. For example, number 7, there's the second one. Let's go. So we'd add 6 and add 6 to each side of this inequality. Then we divide by 3. So we get x is less than 16 thirds. Are the fractions bothering you? Oh, I'm sorry. Over here, we would subtract 4. Subtract 4, so we get negative. Should I use a different color? Yeah, let's do that. So subtracting 4 on each side. So we get negative 12 is greater than negative 2x. All right. So now what's being done to x? It's being multiplied by negative 2, so I need to divide by negative 2. You thinking about anything there if we're dividing by negative 2? That's 6. That's what I'm thinking, Mr. B. Well, we also got to think about I just divided by a negative, so I definitely got to do the old flipperoo. Yeah, got to flip that. So let's make our number line, put the smaller number on the left, the bigger number on the right. This is just over 5, 5.33333. So 16 thirds goes right there. 6 is bigger than that, so that goes on to the right of that. And we have our part of our solution is less than 16 thirds. Open dot. Shoop. So there's like the left or as you look at it. And then the right or, the right part of the solution set, the temperatures that make it too hot to practice are, let's see, the temperature has to be greater than 6. So open dot at 6, which way is greater than 6? It's this way. Now, if you would have made the boo-boo in here and not flipped it, you would have had this solution set, the first solution set right here, going to the left, and you'd have this solution set also going to the left. That doesn't really make sense. It doesn't make the or picture, and it's just kind of a weird way to set up an inequality. But the vast majority of the time, if you're just doing your math homework and you have both lines going the same direction, you made a mistake somewhere, likely with flipping. But yeah, they shouldn't typically be going the same direction. In real life, you could probably run some scenarios where they would. Yes, you definitely could, but probably not in your math homework.